9th standard ICSE, Anita Prasad, Chemistry, Chapter 7, Gas Laws, Numericals, page 168. Fifth sum. So we begin with easy sums. A 2-liter container of nitrogen had a pressure of 3.2 atmospheres. What volume would be necessary to decrease the pressure to 1 atm at the same temperature? So we always write the data first. Volume is 2 liters. Initially, new volume is asked. Original pressure is given. New pressure is also given in atm. Since temperature is constant, we use Boyle's law. P1 V1 is equal to P2 V2. Substitute the data and get the answer of new volume 6.4 liters. Seventh sum. A certain gas occupies a volume of 1500 centimeter cube at a certain pressure. Okay, 1500 centimeter cube at a certain pressure. When the pressure was altered to 5 atm and the volume was 3000 centimeter cube. Again, the temperature is constant. So Boyle's law, P1 V1 is equal to P2 V2 because they are directly proportional. As pressure increases, inversely proportional. As pressure increases, volume decreases. So substitute the values, we get the answer. 11th sum. A gas occupies 200 centimeter cube at 27 degrees Celsius. So 200 centimeter cube, temperature is in 27 degrees Celsius. We have to convert it into Kelvin before solving. If you use Celsius values in the sum, the whole sum goes wrong. Because V1 upon T1 is equal to V2 upon T2. Volume and temperature are directly proportional. This is Charles' law. Here pressure is constant. As temperature increases, volume increases. And 0 Kelvin is not possible. Imagine if you use degree Celsius and if it is 0 degrees Celsius, then the denominator becomes 0. How can denominator be 0? Anything upon 0 is infinity. And imagining infinity is insanity. The question, what is its volume? New volume is asked at 51 degrees Celsius. Again, convert that into Kelvin. How do we convert degrees Celsius into Kelvin? Add 273. So we substitute and we get the answer of volume as 216 centimeter cube. Next, the 13th sum. A sample of argon gas is cooled. Argon gas is a noble gas. Now I had some chemistry jokes, but all of them are gone. So argon gas is cooled and its volume has changed from 380 ml to 250 ml. If its final temperature was minus 55 degrees Celsius, that's 218 Kelvin. What was its initial temperature? Again, Charles' law, we get the temperature in Kelvin, but the final answer will not be left in Kelvin. We will subtract 273 to get the answer in degrees Celsius. Next, the 15th sum. 4 liters of carbon dioxide is kept at 27 degrees Celsius. Calculate the new volume at 150 Kelvin. So again, volume is given, temperature is given, converted to Kelvin, new temperature is given, volume is asked, pressure is constant, so Charles' law, substitute and get the answer. 17th sum. At constant pressure, a gas at minus 33 degrees Celsius is heated to 127 degrees Celsius. Find the percentage increase in the volume of the gas. So here the initial volume is not given. So let's assume initial volume to be 100 liters or 1 liter or X liters, anything is fine. Because in the end, we don't have to find the actual volume, but we have to find the percentage increase in volume. So this is the assumed volume. This is the temperature given, final temperature given. So using Charles' law, we will find the assumed final volume. Clearly, as temperature has increased, volume has also increased. Now, percentage increase in anything is the change in that thing upon the original value into 100%. That's a math formula. Now, what is the change in volume? 66.67. Yeah, these are not actual values, these are assumed values, but that's okay. That is also good enough to find the percentage. So the increase in volume was 66.67 upon original volume is 100 into 100%, 100 cut, 66.67% is the final answer. That's why I took 100, because calculation becomes very easy in the end. Now the 19th sum on page 169. The volume of a certain gas at constant temperature was found to be 1400 cc and the pressure was 1200 mm. If the pressure is decreased by 30%, find the new volume. Pressure is decreased by 30%. So one method is write the data, volume is given 1400, pressure is given as 1200 mm Hg. Pressure is decreased by 30%, so you can calculate that 1200 minus 30% of 1200, but I'm not going to do all that. You know, when they say decrease by 30%, it means 70% of the P1. If they would have said increase by 30%, it would be 130% of P1. If they say decreased to 30%, then it is 30% of P1. So I'm just going to directly write 70% of P1. If they would have said decreased by 1/5, then the new pressure would be 4/5 of P1. Because 1 minus 1/5 LCM is 4/5. And I'm not going to use the value of P1 at all in this sum, because in the end, P1 is going to get cancelled anyway. Even if I would have put 1200, it would have got cancelled. That value was not even required to solve this sum. Substitute the values, cut, straightforward, we get the answer, volume is equal to 2000 centimeter cube. Next, 21st sum. A fixed volume of a gas occupies 760 centimeter cube at 27 degrees Celsius at 70 centimeter of mercury. So whatever units they use, we have to use those units. If they use ATM, we will use ATM. If they use centimeter of mercury for pressure, we will use centimeter of mercury for pressure. They have asked what is the volume at STP, standard temperature and pressure. What is the standard temperature? Always 273 Kelvin, 0 degrees Celsius. What is the standard pressure? Always 1 atm, sea level pressure, air pressure. But they are using centimeter mercury. So what is the standard pressure in centimeter mercury? 76 centimeter mercury, or 760 millimeter mercury, or 1.013 millibars. And in Pascal, how much was it? 1 lakh?
1.013 into 10 raised to 5 Pascal.
Correct. Or 1 lakh, 1300 Pascal. But they have used centimeter mercury. So I just wrote the data. V2 is left. A sum which involves all three parameters, P1, V1 and T1, means nothing is constant. We'll use neither Boyle's law nor Charles' law, and make sure you write the law for every sum, otherwise I'll cut half. Here we will call it gas equation. By the way, this equation is not complete. There are other factors which we'll study in college level. But for now, it's pretty simple. Substitute the values and calculate. You all know how to calculate. This calculation will be easy because 76 got cut, 00 got cut. 23rd sum. Again, here carbon dioxide occupies a volume is given at STP, so I wrote the STP values myself. Find the volume at this temperature and this pressure, so I wrote all the data. Always write the data first to decide which law to use. Gas equation is to be used here. Substitute the values and solve and get the value of V2. But this calculation is very difficult. First you'll reduce as much as you can, but you will reach a point where you'll get big number upon big number. There is no trick here. Multiplication, division you have to do. These sums are very easy. It's just that in some sums the calculation part is very difficult. If you don't do that, I will cut 2 marks, nothing more out of 3 marks. So don't worry. If you write the formula, the data formula and substitution, I'll give you 1 mark with gas equation. 25th sum. A gas X is contained in a vessel of capacity 10 liters. That means initial volume is 10 liters and initial pressure is 20 atm. If it is connected to another empty container of a similar capacity. So now we will have 2 cylinders of 10 liters capacity each connected with the help of a pipe or something. So obviously the gas will now flow here. So now the volume is doubled and the pressure will be halved. So if the new volume is double, so that's 20 liters, what will be the new pressure by Boyle's law? It will be 10 atm, assuming that temperature is constant out here, which is what they mentioned. 27th sum. A gas at constant pressure occupies this much volume. On heating to 80 degrees Celsius, it expands to occupy a volume of 2400 ml. Find the original temperature. Now, again a very straightforward sum. Pressure is constant, so Charles' law. Remember, here they have given the final temperature and initial temperature is asked. Don't forget to convert it to Kelvin. Substitute and solve. Get the answer in Kelvin, but don't leave it like that. Reconvert it to degrees Celsius by subtracting with 273. 30th sum. When a certain gas is heated, its volume increases by 50%. Whenever you heat something, it expands, its volume increases. Okay, but that is not the explanation why fat people are hot. Okay, that's a different matter. When a certain gas is heated, its volume increases by 50%. So they're not given the volume, so let's assume that volume is 100 liters, or 1 liter, or X liters, doesn't matter, or V1. It increases by 50%, so I'll make it 150 liters. And the pressure decreases to 75%, not by 75%, to 75%. Prepositions matter. So I'm assuming initial pressure to be 1 atm. So the new pressure will be 75% of that, which is 0.7 atm. I could have done 75% of P1 as well, but since these values are easy enough, so I'm choosing to use the values instead of variables. Temperature is given, initial temperature, final temperature is asked, convert it to Kelvin, substitute gas equation, get the answer in Kelvin. That calculation is tough, that there I cannot help. And reconvert it to degrees Celsius by subtracting by 273. Don't use a calculator the way I have used a calculator, you do it yourself. 33rd sum. A toy balloon has a volume of this much. It is filled with helium at a temperature of 17 degrees Celsius. Pressure is given. The new temperature and new pressure is given. Find the new volume. Pressure falls to 40%, not by 40%. If the pressure had fallen by 40%, I would have said that new pressure is 60% of P1. But no, here it is fallen to 40%. So 40% of P1. They have given the value of P1 as 750 mm of Hg, but I have chosen not to use it. Why should I? When P1 will get cancelled. So I wrote all the data, gas equation, convert this to Kelvin, substitute 40% of P1. After cutting, I'm getting this as a final volume. Got it? Now, 22nd sum. It's a challenging sum, so let's do this one. Save the best for the last. At 0 degrees Celsius and 760 millimeter mercury pressure, a gas occupies a volume of 100 centimeter cube. So I wrote all the data. So far, so good. Very straightforward. But now the temperature, the Kelvin temperature, is increased by 1/5. If it is increased by 1/5, can I say that the new temperature is 6/5 of T1? That is 1 plus 1/5. If you do LCM, it is 6/5. You can show all those steps, but I did it mentally. If it was decreased by 1/5, then what would the new temperature be? 4/5. But if it is increased by 1/5, it will be 6/5. If it was increased by 1/3, it would have been 4/3. 1 plus 1/5 is 6/5. LCM. So 6/5 of T1, I'm not going to use the values of T1 and P1, I will use the variables. And the pressure is increased 1.5 times, not increased by 1.5 times, just increased 1.5 times, means it is 1.5 times, means it is 3/2 times of P1. If it was increased by 1.5 times, it would be 250% of the original, means 5/2 into P1, but that's not the case here. And now let's substitute P1, T1, V1 is given, P2 is 3/2 P1, T2 is 6/5 T1, V2 is asked. Well, be careful, numerator's denominator goes to denominator and denominator's denominator goes to numerator, and then I want V2 alone, T1 cancelled, P1 cancelled, this goes up and this goes down, and in the end I get this answer. Hi students, this is AJ sir. If you found this video useful, press the like button. Also, if you'd like to enroll for my test series or online lectures, email me or message me on Instagram. Check my description for more information.